Greetings, welcome to episode 16 of Dr. Will's Software Project Leadership Podcast, Maintainability, Part 3. In the previous two episodes, I defined what software maintenance is and why it might not be considered during development. Today, let's talk about how to build maintainable software. Greetings, I'm Dr. Will, and welcome to Dr. Will's Software Project Leadership channel, where we focus on building real software to solve real problems. When you buy a new car, do you read the owner's manual before operating it? Nobody does. My wife complained the other day that she could never figure out how to get a certain feature of her now 3-year-old car to work. I asked her if she had tried looking it up in the owner's manual. Nope. I suggested that she might try pulling up the online manual where she could probably find a search function to help find that info. And no, I didn't make any other comment. If you've already subscribed to the channel, thank you. If you'd like more content like this, then subscribe and hit the bell below to be notified when new content becomes available. There are three areas of concern when it comes to maintainable software: the documentation, the code, and the implementation. Documentation, if you've never had it defined for you, is basically anything written or drawn that describes the software system. It covers, or should cover, the system requirements, the architecture, the design, and the testing or quality assurance aspects of the system. The code, source code itself, may be written in one or several programming languages. It is the intermediate product of the development process. Wait, what? It's the intermediate product? Isn't the point of this all to develop code? Well, no, it isn't. The point of this is to solve problems. If your source code itself doesn't do that, source code has to be translated into binary for the computer to use it, and then that does it. The code needs to be translated, as I just said, and then deployed to the hardware to be used or tested. Implementation then is the process of implementing the design in source code. It is all of the activities that result in a working system. So it addresses the system-wide concerns about how the code was developed and deployed. So documentation. Nobody likes writing documentation. Look, nobody likes reading documentation. So why bother? People, even maintainers, may not like reading documentation, but well-written, current, correct, consistent documentation makes the maintainers more efficient. It is estimated that programmers now spend between 47 and 62% of their time trying to understand the documentation and logic of the programs. If you're going to write the documentation, write it well. The design tells them how the programmer expected to make the software do what it is supposed to do. And the gap between what it describes and what might actually work is what they may need to fix. Or perhaps the design should work, in which case the gap is between what the design describes and what was actually built, and that will be what they need to fix. Writing documentation is a forcing function to help a developer think through the implementation of the solution. It allows the developers thinking about the solution to be examined by others, in peer reviews, for example, and improves the quality of the code. And better code is easier to maintain. The documentation ought to be descriptive, traceable, and organized. Descriptive means that useful information is contained about the requirements, assumptions, constraints, inputs, outputs, processing components, and their relationships, external interfaces, revision statuses, all of that. It aids in finding useful information about the system without excessive effort and cost. Notice that I said useful information, and that's one of the key points, is that the documentation contains useful information, not just a bunch of blitherings. Traceable, the information can be traced between the documents and from the documents down into the source code. The software maintainer must be able to trace any particular element from the highest levels of the description down into the source code and then back up again. So I can look at the code and work my way back up to what it's supposed to do, or take what it's supposed to do and work my way down into the code. It needs to be organized. Specific information should be easily located using standard conventions and easily understandable terminology. It enhances the use of the documentation. Partition of the system's documentation should reflect the partition of the system. Finally, organizing all the information about a system is a big and difficult task. The bigger the system, the bigger the task. I've always thought that a large project ought to hire a librarian, an actual librarian, somebody trained in library science to help organize all that information, because that is what they are trained to do. Next episode, we'll talk about code and the implementation. But for now, this channel is dedicated to helping software projects succeed, not just in the short term, but in the long. So if you'd like more content like this, be sure to subscribe, hit the bell to be notified when more content is available. Also, if you have any questions, put them in a comment below and I'll be happy to answer them later. That's it for me, for you for now. You have a great day and a great week. Be careful out there. I'll be seeing you. Bye.